Welcome to this session on artificial intelligence in quality management according to the VDA Yellow Print draft. Today we explore how AI practically supports FMEA moderators. This new volume focuses on facilitating access to AI while ensuring that technical evaluations and ultimate responsibility remain firmly with the human moderator. Our goal is to develop you into competent users who can assess risks based on clear facts. Let us dive into how AI complements your expertise and serves as a powerful supportive layer in the risk process. Our journey today is structured to give you a comprehensive overview of AI's role in FMEA. We start by classifying the importance of this VDA volume, showing why it is a critical reference for modern QM. It is vital to understand that AI acts as support, not a substitute for your hard-earned competence. We will then examine exactly what AI can achieve, such as generating suggestions or finding similar historical cases, while also defining what it must never decide. This distinction is why FMEA remains an expert task. Moving forward, we address the new requirements for moderators. You are evolving into a technical translator between human experts, established methods, and AI tools. This shift requires a sharp eye for plausibility. We will also tackle the inherent risks of dealing with AI, including the dangers of hallucinations, bias, drift, and the notorious black box effect. These challenges make traceability and auditability more important than ever before. In the latter half, we look at the transition from classical moderation to AI-competent FMEA leadership. We will discuss the specific skills you need for the future and how our specialized training at Quality Services and Knowledge prepares you for these changes. Finally, we conclude with the core message. AI does not make the human element redundant. It makes high-quality moderation even more indispensable. This clear chapter structure will help us focus on each dimension of your professional development. Let us begin with the first section on VDA relevance and the basic classification of these new technologies in our risk processes. Having looked at our roadmap, let us focus on the core integration of AI in quality management. The fundamental principle here is that AI serves as a practical tool, not a takeover of QM. This requires new competencies from everyone involved. As AI delivers suggestions faster, the human role becomes more critical to technically check and responsibly translate these into risk decisions. Chapter 6.4 of the VDA volume specifically discusses AI-supported FMEA as a primary application. To understand this, we must compare AI functions with FMEA responsibilities. AI excels at providing data suggestions, finding similar cases, and preparing information using techniques like retrieval augmented generation or RAG. It can suggest error correlations, detect patterns via anomaly detection, and check for completeness. However, the technical examination and the FMEA responsibility remain human tasks. For instance, securing and evaluating causal chains technically through cause logic is something the moderator must do. The risk assessment itself relies on the expertise of the team, not an algorithm. Furthermore, establishing responsibility and prioritizing actions is a human decision-making process. AI provides the tools, but ensuring traceable documentation for auditability is a strategic human function. In short, AI supports, the human decides, and the team is responsible. We must balance these roles to ensure that technical prioritization remains a human task. The memorandum is clear. Efficiency through technology must be paired with methodological accuracy and personal accountability. This synergy allows us to turn AI-generated data into reliable risk decisions. Now let us look at the specific technical examination steps to ensure your FMEA results remain robust and auditable in this new landscape. To bridge the gap between high-level theory and automotive reality, we must understand why the VDA guideline is so vital for FMEA work today. It acts as a crucial link connecting international standards and European regulations with practical, audit-ready guidance. Let's start with the foundation, DIN and ISO 22989. This standard provides the internationally harmonized terminology for AI systems, serving as our essential linguistic basis. Without a common language, we cannot accurately describe risks or system behaviors in a way that auditors understand. Then we have the regulatory layer, the EU AI Act. This is mandatory and introduces risk classes, requiring a documented quality management system specifically for high-risk applications. For an FMEA moderator, this means that if your process uses high-risk AI, your documentation must meet these legal benchmarks. This is exactly where the VDA guideline fulfills its bridge function. It translates these abstract requirements into practice-oriented recommendations for action within automotive quality management. It moves us from basic standards and strict regulations toward a state of audit-ready practice. This transition focuses on 5 key pillars: competence, structure, approval, validation, and responsibility. By following this practice-oriented translation, FMEA moderators can ensure their use of AI is not just efficient, but fully compliant with the evolving landscape of automotive quality management. We aren't just looking at algorithms, we are looking at a structured approach to integrating them into a professional QM environment. This bridge ensures that every step you take with AI is grounded in technical accuracy and regulatory safety, making your FMEA results robust and ready for any external audit. Building on this regulatory framework, we must clearly define the boundaries between machine support and human judgment. AI is a powerful tool for acceleration, but it is never a replacement for FMEA expertise. In our daily quality management tasks, AI can process multimodal data, ranging from text and images to complex sensor data. It excels at anomaly detection, identifying patterns in massive datasets much faster than any manual analysis could. Furthermore, through retrieval augmented generation, or RAG, it can provide context-related suggestions based on existing knowledge databases. However, the VDA guideline is very specific about role clarification. While AI provides the inputs, the examination of these inputs is a human task. We talk about 4 central requirements here. First, explainability. Every result must be traceable. You must know why a suggestion was made. Second, auditability. Every decision supported by AI needs documented evidence. Third, and perhaps most importantly, is human oversight. Humans always retain the final decision-making authority. Finally, we have validation. Generative results from an AI must be professionally reviewed and approved by the FMEA team before they become part of the official record. Consider a scenario where an AI detects a pattern in production sensor data and suggests a new failure cause. The AI has done the heavy lifting of data structuring, but it cannot understand the physical context of the shop floor or the strategic goals of the company. That evaluation, that final yes or no, and the ultimate responsibility for that risk assessment remain entirely with the qualified professionals. AI provides the patterns, but humans provide the professional judgment. Now, let's look at the specific mechanism that makes this support possible, the RAG principle. Retrieval augmented generation is the tool that transforms a standard large language model into a context-aware FMEA assistant. While a general LLM generates answers based on its broad training, RAG enhances this by targeting information from your own external data sources. This means the system doesn't just guess, it specifically retrieves relevant documents from your company-owned data. This includes your internal QM databases with previous FMEAs, 8D reports, and test plans. It also incorporates official standards like IATF, 16949, or ISO 31000, and even your specific complaint history from field data and audits. The process works in a logical flow. First, the data sources are identified, then the retrieval step pulls the most relevant datasets contextually. Next, the LLM formulates suggestions based on this specific context. This leads to a concrete FMEA proposal covering failure causes, effects, and recommended actions. For example, if you are analyzing a new brake system, RAG can pull lessons learned from 8D reports of similar systems and suggest highly accurate failure chains. But remember, this proposal is just a starting point. The technical review and formal approval remain the non-negotiable responsibility of the FMEA team. RAG combines your vast corporate knowledge with generative AI to make research faster and more accurate, but it never bypasses the expert eye. It's about leveraging the past to secure the future, ensuring that your FMEA is built on the most comprehensive data available, while keeping the expert firmly in control of the final risk decision. Establishing a clear boundary between AI-driven assistance and human decision-making is one of the most critical aspects of the VDA volume on AI in quality management. While modern generative systems can provide incredibly fast suggestions for failure causes or potential measures, these automated outputs are strictly categorized as assistive support. They are not binding. The final word on evaluations, risk assessments, and official approvals must remain a human responsibility. This isn't just about professional ethics, it's a core requirement for any audit process. One major reason for this caution is the risk of hallucinations. In generative systems, an AI might produce content that sounds entirely plausible and technically sound, but is actually factually incorrect or physically impossible. Imagine an AI suggesting a material change that doesn't exist in your inventory or is incompatible with your welding process. If an expert doesn't catch that, the entire FMEA becomes invalid. Therefore, the mantra for every FMEA moderator is that assistance does not equal a decision. We use a clear checklist. For cause evaluations, the AI suggests, but the human performs the professional assessment. For the choice of measures, the AI lists options, but the team makes the binding decision. And for the final risk approval, only an authorized person can sign it off. Every single AI recommendation must be reviewed, traceably documented, and integrated into a robust audit trail. We must ensure that we never adopt AI suggestions blindly. Human plausibility checks remain mandatory at every stage to ensure that the content is not just linguistically correct, but professionally accurate and reliable for safety-critical systems. Even as we integrate advanced AI into our workflows, FMEA remains fundamentally a piece of expert-driven engineering work. The reason is simple. A high-quality FMEA is built on professional causal modeling. This means understanding the intricate, qualitative relationships between variables in a complex system. While AI is exceptional at identifying patterns in vast amounts of data or suggesting structures based on similarities, it cannot replace the nuanced judgment of a cross-functional team. In the causal chain, we look at the source of an error, such as a material defect or a process deviation, and trace its consequence through to a safety risk. While AI can predict patterns or suggest historical similarities, the expert judgment determines the actual severity and the viability of a measure like a design change or a specific test plan. This leads us to the concept of predictive quality. This approach enables proactive quality assurance by detecting potential issues before they occur. However, it requires a very close collaboration between data science, production, and quality assurance departments. AI predictions provide the data-based patterns, but it is the human expert who reviews them professionally and translates them into responsible risk decisions. Remember, the faster an AI delivers suggestions, the more important the human role becomes. We must ensure auditability by documenting every single decision in a traceable manner. A suggestion from an AI tool is a valuable input, but it does not replace the formal approval by the team. causal understanding and collective team review remain the absolute center of any robust FMEA decision, ensuring that we don't just find correlations, but understand the actual logic of failure. As the FMEA process evolves, the requirements for moderators are expanding significantly. While classic methodological competence remains the foundation, the modern moderator now needs a solid layer of AI-related understanding to lead teams effectively. This doesn't mean you need to become a data scientist, but you must become a qualified user and decision maker within the quality management context. We can view this competence building in 4 distinct stages. First, there are AI fundamentals. You need a basic understanding of machine learning concepts, how models are trained, and how they are validated for quality management applications. Second is the critical field of data quality and statistics. You must be able to evaluate if the data being used is representative and interpret visualizations to spot potential biases. The third stage involves handling large language models, or generative AI. This is where awareness of hallucinations becomes vital. You must be the one to ensure the team critically validates every AI suggestion through rigorous plausibility checks. Finally, the fourth stage is governance and audit. It is the moderator's job to ensure that everything is documented in an audit-ready manner, that approval processes for AI outputs are followed, and that responsibilities are clearly assigned. Moderator training must now bridge the gap between traditional FMEA steps and practical AI validation. You are the link between linked methodology and AI-supported insights. Your role is to examine AI proposals professionally, ensuring that the team doesn't just work through a table, but reaches a truly reliable risk decision. By mastering these new requirements, you lead your organization into a future where human expertise and artificial intelligence work together seamlessly and safely. In the evolving landscape of AI-supported quality management, the FMEA moderator takes on a crucial new identity as a dedicated plausibility checker who ensures that algorithmic speed never compromises safety. As the VDA guidelines emphasize, employees must be capable of interpreting AI results by understanding probabilities and model-based predictions, placing these insights directly into the specific application context of the product or process. You are not just accepting an automated output, you are performing a rigorous two-step process that involves interpreting mathematical results and then critically questioning them against the vast reservoir of expert knowledge within your team. A key mnemonic to keep in mind is that the faster an AI delivers its proposals, the more vital the human becomes who translates them into responsible and safe risk decisions. To standardize this professional control, we utilize a specific 4-point check scheme for every single AI output generated during the FMEA. First, you assess the confidence score to determine if the result is robust, followed by an evaluation of explainability to see if the underlying logic is understandable. Third, you perform a ground truth check to see if the result matches real-world field data. And finally, you establish an audit trail to ensure the decision is verifiable. This professional sequence of moderator review, technical evaluation, and final approval ensures that accountability remains firmly with the human experts. By mastering this check scheme, you bridge the gap between digital processing and human reliability, transforming raw data into a traceable and reliable foundation for risk management. Having established the importance of plausibility checks, we now see the FMEA moderator acting as a vital translator between the human experts, the FMEA methodology, and the AI support system. The VDA volume makes it clear that your role is actually increasing in significance as you become a risk leader who ensures that technical, methodological, and auditable requirements are met simultaneously. On one side, you manage the human element, which brings expert opinion, deep experience, and the spirit of collaborative teamwork to the FMEA session. On the other side, the AI provides rapid pattern recognition, massive data analysis, and complex comparisons that would be impossible to perform manually at this scale. Your specific translation function is to recognize whether these AI proposals are technically sound and methodologically clean before they are transformed into team-capable decisions. Crucially, the VDA framework insists that responsibility for the final outcome never shifts to the machine. While the AI analyzes patterns, the human experts must evaluate the findings. This means the FMEA team remains responsible for the content, while you, as the moderator, lead the structured process toward a consensus. By connecting expert opinion with algorithmic speed, you create a robust risk decision that is both traceable and fully supported by the team. This integration ensures that the FMEA remains a professional, auditable process, where AI support and methodological safety work in perfect harmony. Ultimately, you are the glue that holds these disparate sources of information together, turning high-tech insights into actionable quality strategies. To perform this translation role effectively, a moderator must be intimately familiar with the specific technical risks associated with artificial intelligence, such as hallucinations and bias. According to the VDA standard, there are 4 core risks that demand our professional attention: hallucination, bias, drift, and the problematic black box effect. A hallucination is particularly dangerous because the AI generates an output that appears perfectly plausible but is factually incorrect or entirely unsupported by the provided input data. Similarly, bias refers to a systematic distortion in models or data that leads to erroneous or unfair results, which can severely compromise the objectivity of your risk analysis. We must also watch for drift, which is the change in data distributions over time that impairs model performance, and the black box effect, where a lack of traceability makes results impossible to explain. To address these technical challenges, the FMEA moderator implements structured check rules centered on professional control and continuous monitoring of model performance. Every AI proposal must be professionally checked for correctness and robustness, ensuring that the team never relies on a flawed premise. We also maintain strict human oversight because the VDA guidelines are clear. Humans decide and the AI merely supports the process. By recognizing and addressing these technical risks early, you protect the integrity of the FMEA and ensure the transition to AI is a controlled evolution. Through your expert leadership, the organization moves toward a future where technology enhances our traditional methods without ever replacing human professional judgment. In the highly regulated automotive industry, auditability is far more than a technical formality. It is a central principle. For any AI-supported FMEA decision to be valid, the process must be verifiable, accountable, and compliant with international standards. Auditability describes our fundamental ability to document, evaluate, and verify the processes and results of an AI system in a manner that is completely traceable for both internal reviews and external authorities. This brings us to the concept of seamless traceability. We must be able to look at every single AI-generated proposal and reconstruct exactly how it came to be. We start with the input data. Was it based on field data, FMEA history, or specific process parameters from recent complaints? We must document the origin and quality of this data. Next, we record the specific model version used, including its training and validation status. When the AI generates a prediction with a specific confidence value, the FMEA team does not just accept it, they perform a professional review. Finally, every action is logged in an audit trail. Who checked it, who decided, and who approved it. This is where your role as a moderator is crucial. You ensure that accountability remains with humans. By managing this audit flow, you make certain that AI decisions are verifiable and assigned to a responsible person. Only through such auditable processes can we ensure regulatory compliance and meet the high expectations of our customers during audits. This transparency is the only way to transform complex AI predictions into trustworthy, standard-compliant risk documentation. Building on the necessity of auditable processes, we must examine how the role of the FMEA moderator is fundamentally evolving. The journey from classical moderation to AI competent leadership is not a sudden jump, but a structured four-stage development path. This stepwise integration ensures that expert control is maintained even as we leverage powerful new technologies. In stage 1, we find classical moderation. This is the foundation we all know, mastering the methodology, leading the team, and navigating the 7 steps of FMEA. As we move to stage 2, the moderator begins to use AI for support. In this phase, the AI might suggest potential failure modes or help structure the initial document, but the team remains the primary evaluator. Stage 3 represents a significant shift toward AI competent moderation. Here, the moderator takes on the critical tasks of plausibility checking and ensuring the auditability of AI-generated content. You are no longer just facilitating a discussion, you are leading a high-tech risk process. Finally, stage 4 is the level of the technically responsible decision maker. Even with the most advanced AI support, the final judgment remains human. FMEA is a technical risk process at its core. Evaluations of preventive measures and final risk decisions require a level of expertise and professional intuition that algorithms cannot replicate. AI is excellent at comparing data or condensing historical FMEA content, but it is the moderator who leads the team to a robust conclusion. Your evolution into a risk leader means combining classical methodological security with a new responsibility for auditing and validating AI suggestions. Looking ahead, the question is, what specific skills will a modern FMEA moderator need to navigate this new landscape? To make robust and auditable risk decisions, you will require a competence profile that combines your existing expertise with fundamental AI competencies. At the core, methodological security remains paramount. You must still be the absolute authority on the 7 steps, structural analysis, and the logic of functions and failures. Likewise, your moderation ability to lead interdisciplinary teams and reach a consensus stays essential. But the future demands more. First, you need skills in data quality and validation. You must be able to evaluate input data and test AI results for their technical robustness. Second, you must develop a critical understanding of AI limits, specifically regarding hallucinations and bias. You need to recognize when an AI provides a suggestion that sounds perfectly plausible but is technically incorrect. Third, you are responsible for traceability and human oversight. This means maintaining auditable documentation and ensuring that the final responsibility for any decision never shifts away from the human expert. This 6-area competence mix, blending the classical with the new, is the only way to make FMEA moderation secure in an automated world. Training programs must now focus on this balance of expertise, leadership, and AI awareness. In conclusion, the FMEA moderator of the future does not just manage spreadsheets. You lead a sophisticated process that merges human professional judgment with AI-supported information. By mastering these new competencies, you will be the one who ensures that every risk decision is not only fast but truly reliable and ready for any audit. Building on the 6-area competence mix we discussed, our specialized FMEA moderator training is specifically designed to bridge the gap between human expertise and algorithmic support, while providing quality functions with a clear overview of AI competency requirements. The primary goal is to ensure you can make truly informed decisions about any AI system integrated into your workflow by focusing on 4 essential fields: AI and machine learning fundamentals, data analysis, generative AI, and the critical awareness of ethics and legal risks. You certainly don't need to become a data scientist, but you must become a qualified user and decision maker who can confidently assess AI proposals for plausibility, auditability, and methodological correctness. Our competency matrix guides you through 3 skill levels, from differentiating basic terms like AI versus machine learning to critically evaluating model suitability, so you can recognize complex issues like data drift, quality, or bias, which are vital for validating AI results independently. When working with large language models, the training specifically teaches you how to identify hallucinations and filter out nonsensical proposals while ensuring the auditability of every AI suggestion to make them comprehensible for a third party. This is where human oversight becomes the ultimate safeguard, and you will learn how to define human responsibility while managing the release of AI-supported decisions within the FMEA team. Ultimately, this training systematically builds your capacity to transfer high-tech proposals into audit-ready, responsible FMEA results that satisfy both internal standards and VDA requirements. By mastering these levels, you ensure that the responsibility for safety and quality always remains exactly where it belongs, in the hands of the human expert.